Welcome to this brief talk on the paper published recently titled Equitable Anesthesiologist Scheduling Under Demand Uncertainty Using Multi-Objective Programming. I am Kai, a postdoc at UTSA. Our team also includes Professors Arka Roy, Minho Song, and Frank Rossinia from UTSA, and Deepak Agrawal and Rowan Dravenstadt from the UT Health San Antonio. In this work, we optimize schedules of anesthesiologists, focusing on workload equity while managing uncertainty in clinical demand. Anesthesiologists are one of the most valuable and expensive resources in hospitals, and inequity in workload can lead to job dissatisfaction and ultimately workforce turnover. Anesthesiologist scheduling requires the departmental leadership to plan and deploy clinicians. They need to consider creating optimal work schedules, meeting the demand under uncertainty, and satisfying complex clinical and provider-specific constraints. It is a complex and large-size optimization problem because our clinical partners are the largest anesthesia group in Southern Texas. They provide anesthesia services in 2 large hospitals and a number of clinical units with several anesthesia subspecialties. To cover the complex case mix and clinical demand under uncertainty, they have different clinical shifts, demand and coverage-driven shifts, shifts for subspecialties, and on-call shifts. Further, to create a fully implementable solution, it was essential to consider provider engagement and buy-in from our clinical partners. Thus, from the start, we worked closely with our partners to design the automated scheduling framework to align with the existing scheduling processes. The developed scheduling system has automated medium and long-term scheduling and helped with budgeting and hiring decisions. Ultimately, this was significantly reduced our clinical partners' effort on scheduling. Specifically, we developed a data-driven 2-step anesthesiologist scheduling framework using a mixed integer multi-objective program under demand uncertainty. The 2 steps mimics the existing scheduling process that includes a mid-process review of schedule duration prior to provider assignments. The first step is shift design, leverages the anesthesia case data available in the EHR system. Demand-driven shifts are designed considering the uncertainties of clinical demand using conditional value at risk to account for the extreme high demand in the tail of the distribution of the clinical demand. The second step is the provider assignments, where we assign providers to the designed demand-driven shifts and all other shifts, considering workload equity, consecutive intensive working days, and the number of providers to be deployed. This step considers these objectives as they related to the important metrics for workload equity in our clinic. This framework has been deployed for 2 purposes, for budget and hiring planning, and for monthly anesthesiologist scheduling. In the budget and hiring planning, an epsilon constraint solution method is applied for multi-objective optimization, where we provide the decision makers with 3D non-dominated frontiers to make trade-offs for the optimum solution. In the monthly anesthesiologist scheduling, a minimax iterative solution method is developed to improve solution time and quality when incorporating complex clinical and lifestyle preferences. The testing results show that the minimax iterative solution method achieves the lowest workload deviation and lowest workload for the top workload providers. This scheduling framework was first deployed in September 2020 and has become the key component of operating room scheduling in our partner hospitals. More than 82% of scheduling burden has been reduced on the departmental leaders. The development of the framework has improved the workload variability and the schedule satisfaction by 52% and 10%, respectively. We would like to thank the editors and the 2 referees and the faculty and staff of the Department of Anesthesiology and the UT Health San Antonio for their support in this work.